In this episode, we look at Unit 12, page 87 from our science workbook. Unit 12, Sound and Light. The sounds and sights of the world are carried to us by energy in the form of sound and light. The energy of both is carried from one place to another by waves. Sound and light energy travel in all directions from the source. They get weaker as they move away from their source. Sound waves cannot travel across an empty space or a vacuum. Light waves, on the other hand, can travel through air at a faster speed than sound waves. We see a lightning flash almost when it happens. We may not hear the thunder until several seconds later because light travels nearly 1,000,000 times faster than sound. Sound. All sounds are caused by movements or vibrations. When you take your fingertips and place them against your throat and speak or sing, you can feel sound vibrations. Air causes the vocal cords to vibrate as it passes over them. Sounds need a medium through which to travel, for example, solid, liquid, and gas. The speed of sound depends on the substance through which it is transmitted. Sounds travel quickly through solids, less quickly in liquids, and most slowly in gases. Sounds travel approximately 344 meters per second through air, 1,500 meters per second through water, 3,050 meters per second in wood, and 6,000 meters per second through steel, which is a solid. Sound may be regarded in terms of its intensity or pitch and its intensity or loudness. Intensity is the loudness or softness of a sound. It is measured in decibels. Decibel is a special scale named after Alexander Graham Bell. We turn now from page 87 to page 88. Intensity. So, ordinary environmental sounds on one side of the table, and they give you the decibel rating on the other. So, soft rustle of leaves, 10 decibels. A whisper, 15 to 20 decibels. A quiet home, 40 decibels. Normal conversation, 60 to 70 decibels. Heavy traffic, 80 decibels. Disco music, 110 decibels. And we have painful sounds, which are between 120 to 140 decibels. We move on to frequency. The frequency is the speed at which an object vibrates to produce sound. Pitch relates to frequency in that as the frequency of sound increases, so does the quality of the sound. Pitch refers to the highness or lowness of a sound. A high frequency produces a high-pitched sound, whereas low frequency produces a low-pitched sound. Pitch can be varied by adjusting the length of an air column. Have you ever made a sound by blowing across the top of soft drink bottles? Did you notice that the sound changes as the amount of liquid was reduced? When you blow across the top of the bottles, you make the air inside the bottles vibrate. The more water there is in the bottles, the shorter the air column. The bottle with the smallest amount of water has a longer air column. It is the length of the air column inside the bottle that determines the sound. The shorter the air column, the faster the vibrations and the higher the pitch. The longer the air column, the slower the vibration and the lower the pitch. So at the bottom we have a diagram explaining that. So going from left to right, we see that the amount of liquid increases in the bottle. Bottle number 1 would have the smallest amount of liquid and therefore the longest air column and should vibrate what? The slowest. Therefore, it should have the lowest pitch. The last bottle has the most in terms of water. It would therefore have the shortest air column and would vibrate the fastest. We move from page 88 to page 89. Music. Music is made of vibrations in a regular pattern which produce pleasant sound. Music can be produced by blowing, hitting, and plucking. The musical scale has 8 notes arranged in order. This is called the octave scale. Musical instruments. All musical instruments produce sounds by vibration. In wind instruments, sounds are produced by a column of air vibrating. Here we have a few. We have the horn, we have the trumpet, we have the flute, and the oboe. Next point. In percussion instruments, sounds are produced by something being struck. The tighter the skin of the drum, the higher the pitch. The faster an object vibrates, the higher the sound it makes. Smaller objects vibrate faster than larger objects. So we have the side drum, the kettle drum, the cymbals, and the triangle. Remember that the larger the thing is, the lower the pitch, the smaller it is, the higher the pitch. In string instruments, the sounds are produced by plucking one or more strings. Examples: viola, the cello, and the violin. Changing the thickness of a string is one way to change its pitch. Thicker strings are heavier than thinner strings, so they vibrate more slowly and produce a lower pitch. Changing the length of a string is another way to change its pitch. The longer the string, the lower the pitch. A third way to change the pitch is to change the tightness of the string. The tighter the string, the higher the pitch. We move from page 89 to page 90. Echoes. Have you ever wondered why your voice sounds fuller and more powerful than usual when you sing in the bathroom? It is because the sound waves are reflected by smooth, hard surfaces such as the bathroom walls. The sound waves bounce off like a rubber ball bounces off a wall. Likewise, if you make a sound in an empty house, the sound will be repeated shortly after. This bouncing back or reflecting of sound off a solid object is called an echo. The surface from which the sound is reflected must be the same distance away from you in order to hear an echo. And here we have another diagram explaining the echo. So we have a concrete wall. The sound travels to the wall, and then the sound is reflected to your ears. Sound waves are not always reflected, so they don't always bounce back. If they meet a soft surface such as a cushion, a carpet, a sofa, or a plant, the sounds will be absorbed and will not bounce back. Echo sounding. The use of sound to detect and locate an object by its echoes is called echo sounding. Bats use echo sounding to 1. Tell how far away certain objects are, and 2. To hunt for their prey. Sonar. Sonar is a way of detecting objects and of navigating underwater by sending out sound waves. The term sonar derives from a contraction of sound, navigation, and ranging.